of topics in algebra, including solving equations, linear quadratic equations, factoring, working with exponents, graphing equations, and a lot of other stuff that you learn in algebra. We're going to try to cover that today in this video. So let's begin. Let's get right into it. So let's begin our discussion with numbers. A natural number is a number that's a whole number but greater than 0. So 1, 2, 3, 4, 5. These are natural numbers. A whole number is a natural number that includes 0. An integer are whole numbers that can also be negative. All of these are real numbers, and they're all rational. A rational number is a number that can be put into a fraction using integers. So 2 over 3 is rational. 4 is rational. The square root of 9 is rational because that's equal to 3. So all of those numbers are rational. An irrational number is one that cannot be put into a fraction using integers. So an example would be the square root of 5. If you type in the square root of 5 using a calculator, you're going to get a number that looks like this. 2.2360677, and it keeps on going. So that's an example of an irrational number. It doesn't end. Now, let's say if you have a number like 0.2 repeating. This number goes on forever. It doesn't end, but there's a pattern. 0.2 repeating is 2 over 9. Since it can be put into a fraction using integers, this is a rational number. So if this number goes on forever and you don't see a pattern, it's irrational. So the examples that we've considered are real numbers. Imaginary numbers are numbers that look like this. You might see an I. I is equal to the square root of negative 1. And whenever there's no number here, it's a 2. It's an even number. So anytime you have the square root of a negative number, this is equal to an imaginary number. But if you have the cube root of a negative number, that's equal to a real number. So anytime the index number is an odd number, it's going to produce a real number. If it's an even number, you're going to have an imaginary number if there's a negative sign inside. So now let's go over some basic rules of addition and subtraction. So let's say if you want to add 5 plus 4. Now this is pretty much an easy question, but for some of you who don't like to deal with negative numbers, using a number line can help. So if we start with 5, whenever you're adding, move to the right on the number line. So if you're adding 4 to 5, go 4 units to the right. If you count it, this is 6, 7, 8, 9. So now let's say if you want to find the value of 6, actually let's change it. Let's say 2 minus 5. Now you know it's negative 3, but using a number line, you can see why. If we start at 2, and if we subtract it by 5, anytime you need to subtract, go to the left. Go 5 units to the left. 1, 2, 3, 4, 5. So this is negative 1, 0. I take that back. That is not negative 1. This is 1, 0, negative 1, negative 2, negative 3. Now what about this one? Let's say if you have negative 5 minus 6. What is the answer to that question? What is the value of negative 5 minus 6? So let's start with negative 5 on the number line. And if we're going to subtract it by 6, we need to move 6 units to the left. So 1, 2, 3, 4, 5, 6. So this is negative 6, negative 7, negative 8, negative 9, negative 10, negative 11. So negative 5 minus 6 is equal to negative 11. Now what about this one? Negative 7 minus negative 4. Whenever you have two negative numbers next to each other, they will change into a positive number. So this is the same as negative 7 plus 4. So if you start at negative 7, add 4 to it. Go 4 units to the right. 1, 2, 3, 4. So this is negative 6, negative 5, negative 4, negative 3. So that's a simple way you can do addition and subtraction. Now you want to get to a point where you don't have to write it down. You can do it mentally in your head. But I just want to go over the basics for those of you who may want to refresh on this concept. So now, let's talk about adding and subtracting numbers, like bigger numbers. So let's say if you wish to add 126 plus 97. So first you add 6 and 7. 6 and 7 is 13. So you need to write the 3 and carry over the 1. What's 1 plus 2 plus 9? 9 plus 1 is 10, plus 2 is 12. So we're going to put a 2 here and carry a 1. And then 1 and 1 is 2, so it's 223. That's 126 plus 97. So that's a simple way in which you can add. Now let's go over subtraction. Let's say if we want to subtract 94, actually let's use 294, and actually let's change it. Let's say 253 minus 167. So how would you do this one? So let's subtract the top number by the bottom number. 3 minus 7, that's a negative number, so we're not going to do that right now. We're going to borrow a 1 from the 5. So the 5 is going to become a 4, and the 3 will now be a 13. So 13 minus 7 is 6. Now if we subtract 4 by 6, we're going to get a negative number. So we need to borrow another 1 from a 2, and that's going to turn into a 1. And a 4 will be a 14. So 14 minus 6 is 8. And 1 minus 1 is 0, so it's simply 86. If you have your calculator, you can check it. 253 minus 167 is indeed equal to 86. And now let's try another example. Let's say if we wish to subtract 124 from 268. How would you do it? So notice that the 268 is bigger, so you're going to get a negative number. So instead of subtracting it this way, let's reverse the numbers. Let's subtract 268 by 124. Now this is going to give us a positive number. Whatever answer we get, we're going to just put it here and add a negative sign. And the answer will be the same. So 8 minus 4 is 4. 6 minus 2 is 4. 2 minus 1 is 1. So it's 144. So therefore the answer is negative 144, since we reversed it. And that's how you can subtract two numbers if you're going to get a negative number using that technique. Now let's talk about multiplication. So let's say if we want to multiply 74 by 26. How can we do it? 6 times 4 is 24. Add the 2. 6 times 7, that's 42 plus 2. So that's 44. Next, add a 0. 2 times 4 is 8. Let's get rid of this 2. We don't need it anymore. And then 2 times 7, that's 14. And then let's add the two numbers. 4 and 0 is 4. 4 and 8 is 12. Carry the 1 over. 4 plus 4 is 8 plus 1, that's 9. And then the 1 drop down. So 74 times 26 is indeed 1924 if you check with the calculator. So that's how you can multiply two numbers by hand. So let's say if we wish to divide 299 by 13. How can we do it? Whenever you have a fraction, it basically represents division. You're dividing the numerator by the denominator. So to divide 13, or 299 by 13, let's write it this way. Let's put the 13 on the outside and 299 on the inside. So how many times does 13 go into 29? let's make a list. If we keep adding 13, 13 plus 13 is 26. 26 plus 13 is 39. So if you add 13 3 times, you get 39, which means 13 times 3 is 39. 39 is too much, it exceeds 29. So we need to use the 26. 13 times 2 is 26. Next we need to subtract. So 29 minus 26 is 3. And then we need to bring down a 9. So how many times does 13 go into 39? We know it's 3 times, because 3 times 13 is 39. And so we have a remainder of 0. Therefore, 299 divided by 13 is equal to 23. So that's how you can divide two numbers using long division. So now let's move on into fractions. So let's say if you want to add two fractions. 3 over 5 plus 2 over 7. How would you do it? Here's one technique that can work. 5 times 2 is 10, and 3 times 7, that's 21, and 5 times 7 is 35. So 21 plus 10, that's 31, so it's 31 over 35. Now, another way in which you can get the same answer is by getting common denominators. So for the second fraction, multiply the top and bottom by 5. And for the first one, multiply the top and bottom by 7. So 7 times 3 is 21, and 7 times 5 is 35. 2 times 5 is 10. So 21 plus 10 is 31. As soon as the two denominators are the same, you may add the numerators. So now, what about this one? Let's say if we have 4 over 7 minus 5 over 9. So we can use this technique. 4 times 9 is 36, and 7 times 5 is 35. 7 times 9 is 63. By the way, the 36 should come first because the 4 comes before the 5. So it shouldn't be 35 minus 36, it's 36 minus 35. So when you subtract, you have to be careful with the order in which you write it because it is important. When you're adding, it doesn't matter. So the final answer is 36 minus 35, which is 1. So it's 1 over 63. Now what about this one? Let's say if we have 2/3 plus 4 over 3. Well, actually, let's say 4 over 5 minus 1 over 6. So if you're adding and subtracting 3 fractions, what do we need to do? So I really wouldn't use the crisscross method because it works well for 2 fractions. Instead, what I would use is the common denominator. We need to find that. So what number can 3, 5, and 6 go into? 5 times 6 is 30, so 5 and 6 can go into 30. 3 can go into 6, so 3 can also go into 30. Let's multiply top and bottom by, let's attempt to get a common denominator of 30. So, in order to get a 30 for the third fraction, we need to multiply the top and the bottom by 5, because 6 times 5 is 30. In order to get a 30 for the first fraction, we need to multiply top and bottom by 10. And to get a 30 for the second fraction, we need to multiply top and bottom by 6. So each fraction will have a denominator of 30. 10 times 2 is 20, 6 times 4 is 24, and 1 times 5, well, that's just 5. 20 plus 24 is 44. 44 minus 5 is 39. So the final answer for this problem is 39 over 30. But it turns out that we can reduce it. 30 and 39 are divisible by 3. 39 divided by 3, that's 13. And 30 divided by 3 is 10. So this is the answer in its reduced form. Now, how can we multiply two fractions? So let's say if we have 7 over 6 multiplied by 5 over 9. What can we do? Whenever you need to multiply two fractions, multiply across. 7 times 5 is 35. And 6 times 9 is 54. And that's all you gotta do when multiplying two fractions. But now let's say if you have two fractions that contain very large numbers. Let's say you have 60 over 60 over 28 times 35 over 48. What would you do in this case? Would you multiply across? Now, when multiplying fractions with very large numbers, it's going to be very helpful if you can break those numbers into smaller numbers. For example, 60 is 12 times 5. 28 is 7 times 4. 35 is 7 times 5. And 48 is 12 times 4. So notice that we can cancel a 12, we can cancel a 7, and that's about it. So what we have left over on top is 5 times 5, and that's 25. And on the bottom, 4 times 4, which is 16, and this is the answer. It's 25 over 16. Now, what if you need to divide two fractions? Let's say if you have 12 over 5 divided by 4 over 15. If you need to divide two fractions, use the expression keep, change, flip. Keep the first fraction the same, change division to multiplication, and flip the second fraction. So now we can multiply across. 12 is 4 times 3. 15 is 5 times 3. And so we can cancel a 4, and we can cancel a 5. So the final answer is simply 3 times 3, which is 9. Now let's say if you get a fraction that looks like this, 7 over 8 divided by 16 over 21. If you get a fraction that looks like this, rewrite it as 7 over 8 divided by 16 over 21. And then using the keep, change, flip, this is the same as 7 over 8 times 21 over 16. So there's nothing we can cancel here. 21 can be broken into 7 and 3, and there's no 3 in 16 or 8. So therefore, we have to multiply across. So what's 21 times 7? 20 times 7 is 140, because 2 times 7 is 14. If you add a 0, you get 140. And 7 times 1 is 7, so this is going to be 147. Now what about 8 times 16? 8 times 10 is 80. 8 times 6 is 48. If you add 80 and 48, you're going to get 128. And so this is the answer, 147 over 128. Now what should you do if you have a complex fraction? Let's say you have 5 over 1 plus 1/3. How can you simplify this expression? So what you want to do is get rid of the small fraction in the large fraction. So notice that the denominator of the small fraction is 3. Therefore, multiply top and bottom by 3. So 5 times 3 is 15. On the bottom, we're going to distribute the 3. So 3 times 1 is simply 3. And 3 times 1/3, the 3's cancel, and you're just left with 1. 3 plus 1 is 4. So it's 15 over 4. Let's try another example like that. So let's say if we have 7 minus 1/2 divided by 5 plus 1/3. So notice that we have two mini fractions within the larger fraction. So you want to multiply by the common denominator, which is 6. So let's distribute the 6. 7 times 6, that's 42. And then 6 times 1/2 is the same as 6 divided by 2, which is 3. On the bottom, we have 5 times 6, which is 30. And 6 times a third, or 6 divided by 3, that's 2. 42 minus 3 is 39. And 30 plus 2, that's 32. So this is the answer. Now the next thing we're going to talk about is how to convert an improper fraction to a mixed number. So let's say if we have 11 over 4. So how many times does 4 go into 11? 4 goes into 11 2 times. 4 times 2 is 8. So we're going to break the fraction into 8 over 4 and 3 over 4. Notice that 8 over 4 plus 3 over 4 is 11 over 4. 8 divided by 4 is 2. 2 plus 3/4 is the same as 2 3/4. So that's a simple way in which you can convert an improper fraction into a mixed number. Let's try another example. So 19 over 5. 5 goes into 19 3 times. 3 times 5 is 15. So we're going to break it into two improper fractions. 15 over 5 and 4 over 5. 15 divided by 5 is 3. 3 plus 4/5 is the same as 3 4/5. Now, how can we convert a mixed number into an improper fraction? So let's say if we have 2 4/5. What do we need to do? So the 5 is going to remain on the bottom. Multiply 2 and 5 and add the numerator 4. 2 times 5 is 10. 10 plus 4 is 14, so it's 14 over 5. Let's try another example. 5 3/7. So the 7 is going to stay the same. 5 times 7 is 35 plus 3, that's 38. Now the next thing we need to go over is converting fractions into decimals. How can we convert 1 over 7 into a decimal? The simplest way to do this is to use long division. Whatever is in the denominator or the bottom of the fraction is going to go on the outside. The 1 is going to go on the inside. Now 7 doesn't go into 1, so we need to add a 0. 7 goes into 10 one time. And 7 times 1 is 7. 10 minus 7 is 3. So let's add another 0. How many times does 7 go into 30? 7 goes into 30 4 times. 7 times 4 is 28. And so we have 2 remaining. And so let's add another 0. 7 goes into 20 2 times. And we can stop here because this number is going to go on forever. So we can say 1 over 7 is approximately 0.14. So that's how you can turn a fraction into a decimal. Now what about the reverse? How can we turn a decimal into a fraction? So 0.3, what is that as a fraction? You can put it over 1, and if there's only one digit after the decimal place, multiply the top and bottom by 10. 0.3 times 10 is 3. 1 times 10 is 10. So 0.3 is basically 3 over 10 as a fraction. So now let's say if we have 0.24, if there's two digits after the decimal, multiply top and bottom by 100. 0.24 times 100 is 24. 1 times 100 is 100, and then reduce it. Half of 24 is 12. Half of 100 is 50. So we can divide it by 2 again. Half of 12 is 6. Half of 50 is 25. And so 0.24 is 6 over 25 as a fraction. So now let's go over percentages. If you have 57%, how can you convert this number into a decimal? To convert a percentage into a decimal, divide it by 100. 57% is the same as 0.57. 90% is 0.90. 8% is 0.08. 0.5% is 0.05. I mean, not 0.05, but 0.005. There we go. Now, sometimes you may get a question that asks you, what is 20% of 50? So, how would you figure this out? There's an equation that goes like this. Is basically equal to the percentage multiplied by of. So we're looking for what is 20% of 50. We're looking for the is part. So we need to multiply 20% by 50. 20% as a decimal is 0.20. So what's 0.20 times 15? 0.20 times 10 is 2. And 2 times 5 is 10. This is going to be 10. If you take a calculator and multiply it, you should get 10. Another way you could see it, what's 10% of 50? 10% of 50 is 5. So 20% is twice the value of 5. 20% must be 10. That's another way you can see it. So try this one. What is 35% of 80? So you can either multiply 0.35 times 80, or you can do it mentally. So let's find out what 10% of 80 is. 10% of 80 is simply 8. Just move the decimal 1 unit to the left. So 5% is half of that. 5% is half of 8, so therefore 5% is 4. 30% of 80 is 3 times the value of 10%, because 10 times 3 is 30. So then 30% is going to be 8 times 3, which is 24. So if we want to find 35%, simply add these two numbers. So 24 plus 24 plus 4 is 28. And so 35% of 80 is 28. So now let's move on into variables and exponents. X to the third multiplied by x to the fifth power. What is that equal to? When you multiply common variables, you should add the exponents. 3 plus 5 is 8, so this is x to the 8. When you divide, you need to subtract. So 7 minus 3 is 4, this is x to the 4. And when you raise one exponent to another exponent, you need to multiply. 4 times 5 is 20. And anything raised to the 0 power is always equal to 1. So if you have 4xy squared, all raised to the 0 power, this entire expression is equal to 1. Now you need to know what to do when you have a negative exponent. For example, x to the negative 4 is the same as 1 over x to the 4. And 3 over x to the negative 2 is the same as 3x to the positive 2. If you move x from bottom to the top, or the top to the bottom, the exponent simply switches sign. So let's say if you have 5x squared y to the third raised to the second power. What is this equal to? So we need to multiply each exponent by 2. So 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6. Anytime you raise one exponent to another, you need to multiply. 5 squared, that's 5 times 5. You're multiplying two 5s together. So it's 25 x to the 4, y to the 6. Let's try another example. Let's say if we have 2 squared, x to the 4th, y to the 5th, z to the 7th, raised to the third power. So we're going to multiply every exponent by 3. So 2 times 3 is 6, 4 times 3 is 12, 5 times 3 is 15, 7 times 3 is 21. Now what's 2 to the 6? 2 to the 6, you can break that down into 2 to the third times 2 to the third, because 3 plus 3 is 6. 2 to the third, you're multiplying 3 2's together. It's 2 times 2 times 2, which is 8. So this is 8 times 8, which is 64. So 2 to the 6th power is 64. So the final answer is 64, x to the 12th power, y to the 15th power, and z raised to the 21st power. Now let's say if we have 35 x to the third power, y to the negative fourth, z to the sixth power, divided by 14, x to the 8, y to the negative 2, and z to the negative 7, all raised to the second power. So how would you simplify this expression? So we can either divide 35 and 14 and everything else, or we can raise everything to the second power. Now, it's better if we cancel, if we simplify before you raise it to the second power, because 35 squared, that's a big number. So let's focus on the inside part first. 35 is 7 times 5, and 14 is 7 times 2. Now what's x to the third divided by x to the 8? So it's 3 minus 8, it's x to the negative 5. And what's y to the negative 4 divided by y to the negative 2? If you subtract it, it's negative 4 minus negative 2, which is the same as negative 4 plus 2, so that's negative 2. So we're going to have y to the negative 2 on top. Initially, after you subtract it, you should place it on top. And then for the other one, it's 6 minus negative 7. Since we have two negatives right next to each other, this is the same as 6 plus 7. And so what we have is z to the 13. And all of it is squared. So we can cancel a 7. And any negative exponent that we have, we want to make it positive. So we have a 5 on top. We're going to keep the z to the 13 on top. The 2 is in the bottom. And x and y, we're going to move those variables to the bottom so that the negative 5 will become positive 5. And the same will happen to the negative 2. It's going to change to positive 2. And this is still raised to the second power. So now we can square everything. So let's multiply every exponent by 2. So we have 5 squared. 13 times 2 is 26. And then 2 squared. X to the 10th power, y to the 4th. 5 squared is 25. And 2 squared is 4. So this is the final answer. By the way, when you're dividing x cubed by x to the 8, or let's say x to the 5th power, so as we did before, you can subtract them, and you're going to get negative 2, initially, which is on top. And then you can move it to the bottom and get x squared. That's one way of seeing it. Another way you can see this problem, you can see it this way. On the bottom, you have 5 x's. And on top, you have 3 x's. So 3 are going to cancel with each other, so you have 2 left over in the bottom. So it's simply 1 over x squared. That's another way that can quickly help you to see what the appropriate answer is going to be. Now, let's say if you have this expression, 5x squared y to the negative 3 over 9x to the negative 4 y to the 5th power. So how can we simplify this expression? So the first thing I'm going to do is I'm going to move the negative exponents into the other side to make them positive. So I'm going to keep the x squared on top, but the x to the negative 4, I'm going to move it to the top. And the y to the negative 3, I'm going to move it to the bottom. So this is another way you can solve it. And so now I can multiply these two, and you can clearly see that it's going to be x to the 6th power. And multiplying y to the 3rd by y to the 5th, I can add 3 and 5, and that's going to give me 8. So this is another way you can do it too. Now let's briefly go over exponential fractions. So here's one, x to the 3 halves. You need to be able to convert this into a radical. This is the same as the square root of x cubed, where the index number is a 2. So let's say if you have x to the 5/3, how can we convert that into a radical expression? And try this one, x raised to the 7 over 4 power. So this is going to be the cube root of x to the 5th and this is the 4th root of x to the 7th. Now you also need to be able to simplify radical expressions. What is the square root of x to the 4? So the index number is a 2 if you don't see it there. So how many times does 2 go into 4? 4 divided by 2 is 2. So this is simply x squared. Likewise, the square root of y to the 6 is 6 divided by 2. It's y to the 3rd. And the square root of z to the 10th power, 10 divided by 2 is 5, so it's z to the 5th power. Now what about the cube root of x to the 12th power? And the cube root of x to the 17th, and let's say the 4th root of x to the 19th. So, starting with the cube root of x to the 12th, we can just divide it. 12 divided by 3, that's 4. So it's x to the 4. But in this case, 3 doesn't go into 17 evenly. How many times does 3 go into 17? 3 goes into 17 5 times, because 5 times 3 is 15. So now what's remaining? 17 minus 15 is 2, so we have 2 x's remaining. And so this is the answer. It's x to the 5th times the cube root of x squared. Now for this one, how many times does 4 go into 19? 4 goes into 19 4 times, because 4 times 4 is 16. And 19 minus 16 will give us a remainder of 3. So we're going to have the 4th root of x to the 3rd. So this is going to be the remainder. Now, what about this problem? What is the cube root of x to the 6, y to the 9, z to the 14? So 6 divided by 3 is 2, 9 divided by 3 is 3, and 3 goes into 14 4 times. So we're going to have z to the 4 on the outside times the cube root of 14. Well, we said 3 times 4 is 12. 3 goes into 14 4 times, so 4 times 3 is 12, and 14 minus 12 is 2, so there's 2 z's remaining. So this is the answer, x squared y cubed z to the 4 times the cube root of z squared. Try this example. The square root of 25 x to the 8, y to the 9, z to the 10. So we know the square root of 25 is simply 5. And we need to divide every number by 2. 8 divided by 2 is 4. 10 divided by 2 is 5. Now 2 goes into 9 4 times. 2 times 4 is 8. So 9 minus 8 is 1. We have 1 remaining. So this is just going to be the square root of y, or y to the 1st power. So this is the answer for that particular example. Now what about this one? The cube root of 8x to the 12th, y to the 17th, and z to the 21st power. Feel free to pause the video and try this example. So the cube root of 8 is 2. 12 divided by 3, that's 4. 3 goes into 17 5 times. And 17 minus 15 is 2, so we have 2 remaining. And let's keep the 3 on the outside. 21 divided by 3 is 7, and so that's how you can simplify that example. Now sometimes you might have to simplify an expression that's within a radical and that's associated with division. The cube root of 27 is 3. And the cube root of 125, what times what times what is 125? It's 5. 5 times 5 times 5 3 times is 125. So the cube root of 125, that's 5. Now notice that each of these numbers are divisible by 3. So it's best we apply the exponent. Let's divide everything by 3. X to the 9, or 9 divided by 3 is 3. 15 divided by 3, that's 5. And 12 divided by 3 is 4. and 30 divided by 3 is 10. So now we can reduce it. So x to the third divided by x to the fourth. We need to subtract it. If we subtract it backwards, 4 minus 3 is 1. So that means that we're going to have one more x on the bottom. If you cancel 3 x's on top and 3 on the bottom, you have 1 left over on the bottom. And 10 minus 5 is 5 on the bottom if you subtract it backwards. So this is the answer. It's 3 over 5x y to the 5th power. Now let's go over equations. So let's say if we have the equation x plus 8 is equal to 20. How can we solve for x? So x is simply a number. It's a number that you currently don't know the value of. So what number plus 8 is 20? That's what we're looking for. It turns out that 12 plus 8 is 20, so x is 12. To get 12, subtract 8 from both sides. Whenever you're solving for x, your goal is to get x on one side of the equation by itself. If you can do that, then you can find the value of x. So here we can see that the 8's will cancel. 8 plus negative 8 is 0. And on the right side, 20 minus 8 is 12. And that's the value of x. That's how you solve for it. So let's try another example. 3x minus 5 is equal to 9. So how can we solve for x? Notice that there's a negative sign in front of the 5. The opposite of subtraction is addition. So let's add 5 to both sides. Nine plus 5 is 14. Now how can we separate the 3 from the x? Notice that the 3 is multiplied by the x. The opposite of multiplication is division. So we need to divide both sides by 3. And so now we have the value of x. X is equal to 14 divided by 3. Now what is 14 over 3? What is that as a decimal? So we can separate 14 into 12 and 2. 12 divided by 3 is 4. And 1/3 is 0.33. 2/3 is 0.66 repeated. Or if you round it, 0.67. So this is about 4.67 as a decimal. Now, let's say if we have the equation 5 times x plus 2 plus 7 is equal to 37. How can we solve for x? Feel free to try this problem and pause the video and then unpause it when you're ready to see the solution. So let's go ahead and subtract both sides by 7. Since the opposite of addition is subtraction. 37 minus 7 is equal to 30. So notice that the 5 is multiplied to the x plus 2. If we divide both sides by 5, we don't need to have the parentheses anymore because there's no number in front of it. So all we have now is x plus 2 on the left side. And 30 divided by 5 is 6. So to separate the x from the 2, they're separated by addition. So let's subtract both sides by 2. So therefore x is equal to 6 minus 2, which is 4. And so that's the answer for this particular problem. So now let's try an example where we have variables on both sides with parentheses. So feel free to solve this equation. In this particular example, I'm going to distribute first before combining like terms. So let's distribute the 3 to the x and the negative 3. So 3 times x is simply 3x. And 3 times negative 3, that's negative 9. We can rewrite the 4. And now let's go ahead and distribute the negative 2 to x and 1. So it's going to be negative 2x and negative 2. So now let's combine like terms. On the left side, we can combine negative 9 and 4. Negative 9 plus 4 is negative 5. And 22 minus 2 is equal to 20. So we have 20 minus 2x. So let's add 2x to both sides. And simultaneously, let's add 5 to both sides. So we can cancel the 2x's on the right side and the 5's on the left. So 3x plus 2x is 5x, and 20 plus 5 is 25. So now the last thing we need to do is divide both sides by 5. So the 5's will cancel on the left. 25 divided by 5 is 5. So this is the value of x. That's how you can solve this particular problem. Now let's say if we have a fraction within the equation. How can we solve for x in this particular instance? So before we deal with a fraction, we could subtract both sides by 7. And that should make it a lot easier. So what we now have is 2/3 x is equal to 11 minus 7, which is 4. Now notice that we have a 3 in the bottom. The best thing to do in this particular case is to multiply both sides by 3. Because on the left side, the 3's will cancel. So on the left side, all we have is 2x. And on the right side, 4 times 3, which is 12. So now we could just divide both sides by 2. And so therefore, x is equal to 12 divided by 2, which is positive 6. Let's try another example like that. So let's say if we have 3/7x is equal to, let's say, 21. So instead of multiplying just by 7, another thing that you could do is you can multiply both sides by the reciprocal of the fraction. That's by 7/3. And so at the same time, the 3's will cancel and the 7's will cancel as well. So on the left side, you just have x. And on the right side, you have 21 times 7/3. You can put this over 1. 21 is basically 7 times 3. And then we're going to multiply that by 7/3. So the 3's cancel. All we have left over is just 7 times 7. So therefore, 21 times 7/3 is 49. Try this example. 5/2x minus 1/4 is equal to 2/3 x plus 1. So here we have a lot of fractions. And in this particular problem, I'm going to multiply both sides of the equation by the least common denominator of those 3 fractions. So what number goes into 2, 3, and 4? The answer is 12. 4 can go into 12, and so can 3 and 2. So I'm going to multiply everything by 12. So 12 times 5/2x, what is that equal to? Well, it's easier if you divide first before you multiply. 12 divided by 2 is 6, and 6 times 5 is 30, and there's an x in front of it, so the first term is 30x. And 12 times 1/4. 12 divided by 4 is 3, so this is simply -3. Next we have 12 times 2/3. 12 divided by 3 is 4. 4 times 2 is 8. And we're going to carry over the x. And 12 times 1 is 12. So now we don't have any more fractions. So now it's a lot easier to solve it. So let's add 3 to both sides. And simultaneously, let's subtract 8x from both sides. So these will cancel. 30x minus 8x is 22x. And 12 plus 3 is 15. So now let's divide both sides by 22 to isolate x. So now we have our final answer. X is equal to 15 divided by 22. Now sometimes you might have an equation that contains decimals. Let's say if we have 0.32x minus 0.15, and that's equal to 0.23x plus 0.21. How can we solve for x under these circumstances? So what you want to do, you want to multiply both sides by 100 because we have 2 digits after the decimal place. So let's multiply everything by 100. Whenever you multiply a number by 100, simply move the decimal 2 units to the right. So 0.32x times 100 is 32x. 0.15 times 100 is 15. And so we're going to have 23x and 21 on the other side. And so now it's much easier to solve. So let's subtract 23x from both sides, and let's add 15. So these will cancel. 32x minus 23x, that's 9x. And 21 plus 15 is 36. So now let's divide both sides by 9. So 36 divided by 9 is 4. So x is 4. Now, how would you solve for x if you have this equation? X squared is equal to 25. What would you do? So, in order to solve for x, you want the exponent to be 1. Right now, it's a 2. So, what you want to do is you want to take the square root of both sides. When you take the square root, what you're really doing is you're dividing the exponent by 2. So 2 divided by 2 is 1, so it becomes x to the 1. The square root of 25 is basically the value of a number when you multiply it by itself that will give you 25. 5 times 5 is 25, thus the square root of 25 is 5. Now, it can be positive 5 or it can be negative 5, because positive 5 times positive 5 is positive 25. And negative 5 times negative 5 is also positive 25. So that's why we have two answers in this situation. Now, what about this one? Let's say if we have x to the third is equal to 27. What can we do? So in this particular case, we need to take the cube root of both sides. So 3 over 3 is 1. So we just have x, or x to the first power. So what number times itself 3 times is equal to 27. 3 times 3 times 3 is 27. So the cube root of 27 is only positive 3. It's not negative 3, because negative 3 times negative 3 times negative 3 is negative 27, not positive 27. So if you have an odd index, you're only going to get one answer and not two answers. Now, let's say if we have this equation, x to the 3 halves is equal to 8. How can we solve for x in this problem? So keep in mind, whenever you solve for x, you want the exponent to be 1. Right now, it's 3 over 2. So in order to change it to 1, we need to raise both sides to the reciprocal of 3 over 2. The reciprocal is 2/3. Whatever you do to the left side, you have to do it to the right side, so that the value of both sides of the equation remain the same. So whenever you raise one exponent to another exponent, you're multiplying. So we're multiplying 3 over 2 times 2/3. The 2's will cancel, and the 3's will cancel. So on the left side, what we now have is x to the first power. But on the right side, we have 8 to the 2/3. How can we simplify that? What is 8 to the 2/3? So we could change it to a radical expression. This is the same as the cube root of 8 squared, which I'm going to put the 2 on the outside. You want to take the cube root first and get a small number and then square it, rather than doing it the other way. So what is the cube root of 8? So what number times itself 3 times is 8? 2 times 2 times 2 is 8. Therefore, the cube root of 8 is 2. And 2 squared is 4. So this is the value of x. X is equal to 4. And we could check it. If we plug in 4 into this equation, 4 to the 3 halves, this is the same as the square root of 4 to the third. The square root of 4 is 2, and 2 to the third is 8. So the answer works. So let's try another one. Try this one. X to the 3/4 is equal to 8. So go ahead and practice this problem and see if you can get the answer. So just like before, we're going to raise both sides to the 4/3. So we know 3/4 times 4/3 is going to give us 1. So we just have x on the left side. So 8 to the 4/3 is the same as the cube root of 8 raised to the 4th power. We know that the cube root of 8 is 2. And 2 to the 4th, that's 2 times 2 times 2 times 2, 4 times. And so that's equal to 16. So x is equal to 16. Now sometimes you might get a similar problem, but with more steps. So let's say if we have this problem, x plus 2 raised to the 4/5 plus 5. Let's say it's equal to 21. Go ahead and solve for x. Now the first thing I would do is subtract both sides by 5. So 21 minus 5, that's equal to 16. Next, we need to get rid of the 4/5, so I'm going to raise both sides to the reciprocal, which is 5/4. So once the exponents cancel on the left, there's no need for the parentheses, so we just have x plus 2. So now what's 16 raised to the 5/4? So this is the 4th root of 16 raised to the 5th power. The 4th root of 16, we know it's 2. And 2 to the 5th power. 2 to the 4th is 16. So 2 to the 5th, you just multiply 16 by 2, and you get 32. So what we now have is x plus 2 is equal to 32. And so we just got to subtract both sides by 2. And so now we have the answer, x is equal to 30. Let's try this one. X plus 3 to the 2nd power is equal to 5. Now this one might seem like a simple problem. If we take the square root of both sides, we can get rid of the square on the left side. And so it's x plus 3. But we can't simplify root 5, so we have to leave it this way. And whenever you take the square root of both sides, you're going to get two answers. So this is going to be plus or minus root 5. Now all we need to do at this point is subtract 3 from both sides. Now we can't combine the negative 3 and the root 5, so for this particular problem, you have to leave the answer like this. You can convert it to a decimal, but this is what it is. There's two answers. It's negative 3 plus root 5, and the other answer is negative 3 minus root 5. Now let's try some other problems that involves radicals. So let's say if you have the square root of x is equal to 3. What do you need to do to solve for x? So this time, before, where we had x squared was equal to 25, to solve for x, we need to take the square root of both sides. Now that we have the square root, we need to take the square of both sides. We got to do the opposite. So, once you square a square root, the 2's will cancel. And so, on the left side, all you have is x. 3 squared is 3 times 3, which is equal to 9. And so, that's it for that problem. So let's try another similar problem, but with more steps. So let's say if we have the square root of 2x minus 5, and it's equal to 4. So, just like before, we're going to square both sides. So we don't have the radical on the left side anymore, so we just have 2x minus 5. On the right side, we have 4 squared, which is 4 times 4, and that's 16. So now, let's add 5 to both sides. So, 16 plus 5 is 21. Now, the last thing we need to do is divide both sides by 2. So now we have our answer. It's 21 over 2. And if you want to turn 21 over 2 into a decimal, you can rewrite it as 20 over 2 plus 1 over 2. Since 20 plus 1 is 21. 2 goes into 20 10 times, and a half is basically 0.5. So 21 over 2 is 10.5 as a decimal. Try this one. The cube root of 3x plus 1 is equal to negative 2. So go ahead and solve it. So for this problem, we need to raise both sides to the 3rd power in order to solve for x. So the radical is gone. So we just have 3x plus 1 on the left side. So negative 2 to the 3rd power, that's negative 2 times negative 2 times another negative 2, which is negative 8. So now we can just solve for x, as we've been doing before. Negative 8 minus 1, that's negative 9. And if we divide both sides by 3, we can see that x is equal to negative 3. Here's one, try this one. The square root of x plus 1 plus 3 is equal to the square root of 3x plus 2. So, you don't want to take the square root of both sides right now. You want to try to simplify if you have two radicals. And you want one radical to remain on the left and the other to remain on the right. So what we're going to do is we're going to subtract both sides by 3. So what we now have is the square root of x plus 1 that's equal to root 3x minus 1. So now, we have no choice, but we need to square both sides. If we square it on the left, the 2 and the radical will cancel. So on the left, we'll just get x plus 1. On the right side, we need to FOIL. We need to multiply root 3 minus 1 times another root 3 minus 1 because we have two of them based on the exponent. So we're going to multiply root 3x times root 3x, which will become 3x. For example, the square root of 4 times the square root of 4 is the square root of 16, which is 4. So when you multiply two radicals that have the same inside, the radicals cancel. And this will be multiplied by negative 1, so this is negative root 3x, and root 3x times another negative 1. And finally, negative 1 times negative 1, that's positive 1. So let's make some space. So we can combine like terms on the right side. That's these two. Now keep in